in case you're in those sections as well. There's a PDF file, and I'm going to open it up, I think. Let me see if I have it open already. Here we go. Okay, this is a PDF file that you'll find there. It's our exercise for tonight, exploring data with graphs and numerical summaries. Most of this exercise is going to be using SPSS, and indeed, it actually has a procedure to use with a description of how to find it later on when you're on your own. You can go back to this, and you'll have the actual command menu sequence that you can use to replicate what we're going to be doing tonight. This is about 10 pages long. We're going to be going through it step by step, but for now, we're just going to get introduced to this data file. I just wanted to mention one thing. Some of this information has references to the relevant chapters and section numbers in Agresti and Franklin. It says refer to the required text. As we know, the textbook is not required; it's optional. But these references to where this material in the text is provided anyway. So don't let that make you think that like we changed our minds. The textbook is optional if you want to obtain a copy of it. Let's see. Ari, are you located at home or are you located in C06? I had a request in C06. How about is that pretty much agreed upon for everybody there, that the volume's a little low? Okay. Michelle or Ari or anyone else, if you go to the front of the room behind the computer that controls the display, you'll see a black panel up there with some switches, and one of them is a volume control. Okay. If you go up there, you can turn the volume up a little bit, and I'll keep speaking here and trying to make some noise while you guys get a chance to run up there, and you can kind of regulate what you want the sound at, and so on and so forth. Let me know when you think you have it okay, so I can stop talking before I run out of breath. And I'm not Barbara Streisand up here. I don't have that kind of wind, so let me know if the volume is okay. Okay, you got it? Okay, good. Excellent. Okay, so at least you're able to hear me now. Okay, so I'm going to start by, I've given you this file in 4 different formats. I'm not sure that they're in all these formats if you're in sections 1 or 2, but in sections 3 and 4, you can just look over our shoulder for now. I've put it up there in 4 different formats. I'm going to open it first in Excel, okay, because I want you to get a good look at what this data set looks like. Okay, and Excel is a good place to kind of like just display this and see what we're dealing with. I'm going to blow it up a bit so you can see it a bit better. In this data set has I'm guessing probably 5,000 or 10,000 cases or respondents. Each one of these lines represents a birth in North Carolina during a certain period of time, and there are thousands of lines involved in the original data file. We've modified this file. You notice it says NC birth 800 mod SPSS file. We've modified this file so that it's randomly has random selection of 800 out of those thousands. So this is really a sample from that entire population. One of the reasons we modified it because there are a few student versions of SPSS that are running around that are limited to 800 cases. Okay, that probably is not the case if you've downloaded it recently within the last, if you're using a version within a student version that was licensed within the last 5 years, if it's still running. But we still kept that. And 800 is certainly enough cases for us to work with effectively. And I just wanted to show you that what's in here is that we have a data set where we have 1, 2, 3, so on and so forth, up to whatever O is, I guess like about maybe 18 variables. Each one of the variables has a name. Sex is obviously sex is the gender of the baby, not the mother. So this is 1 might represent a male baby, 2 might represent a female baby, or the other way around. We can't tell really from the Excel file, can we? Okay, if we have the SPSS file, hopefully it's been coded so that we can actually tell which one is male and which one is female. Okay, now the next column, for instance, I'm not sure what plurality is, but we'll take a look at that as we go. That might be coded also. Mother's age at the birth of the child, the weeks of gestation, the marital status of the mother, the race of the mother. Again, this is a categorical variable. You can see, for instance, it's at least 8 different categories. I see that number, for instance. Whether or not it was a Hispanic mother, uh, for whatever reason, they singled out that particular ethnic group. The amount of weight the mother gained during the pregnancy, whether or not the mother smoked during the pregnancy. Zeros might be she didn't smoke, one might be that she did smoke, whether or not she drank alcohol during the pregnancy, what the birth weight of in ounces of the baby was, what the birth weight in grams that the baby was, whether it was from a low income family, whether the baby was premature, which probably is based on the number of weeks that of gestation. And the last column was the ethnicity of the mother. I'm not sure how that differentiates from the other ethnicity, but we're using this as an exercise. If you really want to get this information down a little bit tighter, we're going to look at a code book. Very frequently, the data comes with a code book that explains explicitly what each one of these variables represent, how the data was collected, and so on and so forth. Okay, so we're going to play with this data. Now, we could certainly work with it in SPS in Excel. There are certain exercises that we started playing around with last week that we could do. For instance, if we wanted to know what the average mother's age was, we could actually calculate it. We could say that we want the average of all the values from C2 down to C801, I'm guessing. C801. So actually, I could do that. Equals average, parentheses, C2, colon, C801. And hit enter, and the average age is 29.915. Age expressed as a decimal rather than days and months and so on and so forth. Okay, so that's easy enough. We can use Excel to do that. It's a little tedious to do that with all these columns and so on and so forth. And some data will be interested in the average, will be interested in the deviation, in the range, and so on and so forth. A lot of the variables, a lot of the types of statistics that we were talking about last week. In some cases, that really doesn't make any sense. So, for instance, when we're looking at the gender of the baby, the sex of the baby, where we're not interested in the average, we're interested in a count, for instance, the frequency. So, in other words, we might be interested in how many male babies were there out of 800, how many female babies were there out of 800. So, that's a frequency. An average really doesn't make any sense to us. It really doesn't give us any value. Where if we have a numerical variable, then average does make sense. Number of weeks of gestation, numerical variable. The marital status is a categorical variable, married or not married, and that again for categorical variable, we're interested in frequencies. How many out of the 800 are married? How many are not married? And so on and so forth. So I'm going to close this, and we're going to do most of our work today with SPSS. And SPSS, because it's a piece of software that's specifically designed to do these calculations, is going to do this work much more efficiently than trying to highlight a list of 800 numbers and so on and so forth. Imagine this went pretty easily with 800 numbers. Imagine now if there were 16,000 data or lines for 16,000 births in North Carolina during this period of time, and we had to use Excel to work with that kind of file. Wouldn't be very easy to deal with that size spreadsheet. So I'm gonna minimize this, get it out of the way, and I'm gonna open my file in SPSS. There's two ways I can do this. One is I can double click this file, this file that's a .sav file. That's a SPSS data file. Is a .sav file. I can double click this. It should automatically, if it's installed properly on a computer, should automatically open the program that it was created in SPSS. Another way for me to do this, which I want to show you, is for me to find SPSS here. And actually, I'm going to do it this way so I don't go searching around and kill a lot of time. Okay, I'm going to open SPSS. On a PC, you would do this from the Start menu. On a Mac, you can do it from the dock down, what they call the dock down here, or you can do it from by searching for it up here in Spotlight and opening it. It opens in a window that asks you if you want to open an existing data source that you've used before, if you want to open another type file, import, or if you want to run a tutorial, type in data, so on and so forth. It gets you to the right spot. Many people click this off so they don't have to bother with this dialog box at all. If you want, you can do that. I'm just going to say cancel for now and show you how I would open the file from scratch if we're not open. Here's a blank data file for SPSS. Notice it's untitled. I'm going to say File. I'm going to say Open Data. Now, I just wanted to show you that there were 4 options there. I'll come back to that and show you later on. There were 4 options there. Now, my data file happens to be stored on the desktop in a folder called PH750 Session 2. And you'll notice that there's a bunch of files here. There's the CSV file that I gave you for you guys that might be interested in playing around with R, for instance. There's the PDF file that we were just opening with the exercise. There's the XLS file, the Excel file that we had just opened and closed. And there's the SAV file. Notice that's highlighted because that's the only one that I can open right now. I'm going to go ahead and say open. But before I do that, I'm going to do this again. I'm going to say File, Open, Data. Now, SPSS can open other kinds of files. For instance, right now, the only one that I see that it's available for me to open in this folder is that .sav file. If I go here to Format and change that to Excel files, it will now recognize Excel files. See, there's a couple of Excel files here. I think one of them is probably a file that I didn't close, that's open right now. That's why that's got that little squiggle there. But here's another version of the Excel file. Now, what SPSS will allow me to do is it'll allow me to import an Excel file. So I could literally say, open that Excel file. It'll tell me it sees data in rows from cell A1 to cell A0801. Sounds like our data, right? And it'll ask me, do I want to read the variable names from the first row of data? Well, if you recall, the first row was our data names. If I click that off, it'll try to import that as a data, as a person, right? We don't want that. We want it to read it as a variable name, which it is. Now, if I leave that on and there are no variables in the first row, well, then it's going to try and use that row of data as variable names. So we got to make sure we check that correctly when there's a variable name in the top row of the Excel file, or uncheck it when there's no variable name there, so we don't lose a row of data. So I'm going to click OK, and SPSS is going to import that data. Now, the first thing that you saw pop up there very quickly is called a syntax window. SPSS has its own programming language, and it's kind of English-like. It's got a few weird characters and expressions in it and stuff like that, but it's readable, virtually readable in English. And what this does is it gives us in Excel's syntax language, in Excel's programming language, it gives me the procedure that I just executed by using the dialog boxes or the menus and so on and so forth. In other words, this is a description of what we would tell SPSS if we wanted it to open this file and import as an Excel file. Here's the route to the file. Here's what cell range is full of. We want all of it. Read names on is probably telling it that first row is the variable names, and telling it to execute it and bring the window, the dataset 1 window to the front, which it did. We had to go back to the back for this. We can actually run this again. It'll just we can take this and tell it to run, and it'll repeat this whole process. So later on in the semester, we're going to get into this syntax window because it may be of some value to you, or it may not. You may want to just stick to using the simpler menus and drop boxes, drop menus, and and dialog boxes and so on and so forth. That's entirely up to you. You really don't need to know this to do a lot of good things with SPSS. So I'm going to look at what this looks like. And you'll see here, it imported all of the variable names and it imported all of the data, 11111, 22222. Now, it made some funny selections in terms of decimal places and so on and so forth, but that's okay. Now, one of the problems with importing it into Excel is it imports the actual numbers. It doesn't tell you what those numbers represent. Like, for instance, does the number 1 represent male or female for the sex of the baby? For that, we would have to go to the variable view. I'm going to click on variable view down here. I don't know how easy it is for you to see this whole page. Maybe I can shrink it a little bit so that you can see a little bit, make sure you can see it. Click on variable view. Under sex, it doesn't define the values. See, I can go in here and define the values if I want to. I'm going to skip that for now because we're going to come back to that hopefully at the end of this session. Okay, so I'm going to say cancel. And instead of, I just want to show you that we can import Excel files into SPSS very quickly and easily. We do have a little bit of work to do once we're done explaining to SPSS whether correctly assumed it was a nominal or categorical data, or whether it correctly assumed it was a scalar or numerical data, or whether it was an ordinal data, and so on and so forth. And also what the values mean for the categorical data, like for ethnicity. Where's ethnicity? Ethnicity is, let's see, race of the mother. If I go into the values, right, we would want to know what each one of those values, 1 through 8, represented, what ethnic group they represented. It's not here because that data is not present in the Excel file. Only the number that represented it was present. Okay, so I'm going to close this because we're not going to use it that way. And I'm going to open it the other way I told you about. Let me close that. Okay, it's going to exit SPSS. That's okay. I'm not going to save that. And I'm not going to save the data set. This time, I'm going to double click on the file. And I'm going to cross my fingers, and hopefully it'll open in SPSS. I'm waiting. I'm still waiting. Let me make sure it wasn't hidden here somewhere. Let me try again. Oh, I think that did it that time. There we go. Get the same dialog box coming up, even though we do know we're planning on opening it from that data file. Okay, here we go. Notice our syntax window is in the background there. Actually, I wound up opening it twice. I was a little impatient. Okay, so there's our data. There's our file. Notice this time, by chance, it opened up in the variable view. I'm going to go to the data view. You can see that it shows the same data that we were looking at before. Interestingly enough, instead of 1s and 2s, notice what we have here in this data set. Male and female. It's filled in for us. The reason why it's filled in for us is because I'm going to go up here to view, and I'm going to go here to value labels. These, anytime you see a selection here that has a checkbox next to it, if you click it, the checkbox goes away. I click it again, checkbox comes back. That's called a toggle. Okay, if I toggle this off, I see the numbers in the categories: marital status, sex of the infant, so on and so forth, whether the mother smoked or not. If I toggle this on, I see the value that's represented by that number: male or female, mother divorced, single, so on and so forth, married, mother drank, mother did not smoke, mother did smoke. I can spread this out. Notice you can do a lot of the kinds of things you do in Excel, like spread out the columns so you can see them better if you hover over the edges. However, it's not like Excel. You can't do calculations between these. This is literally just a listing. Columns represent the variable names, the variables, and the rows represent the cases or the respondents. Okay, so now I'm going to go to the data view, the variable view, excuse me. In the variable view, each of the columns is represented by a row. Like this row represents the gender or sex of the baby. Okay, it says it's numeric, meaning that it's a number. That's okay. But if I look at the other end here, the measure, it's chosen nominal. And in fact, it's not a scale, it's not a numerical variable like on a scalar variable. It's not ordinal, it's nominal, it's a name. It's either male or female. Well, how do we know which one it is? Well, if I go into values, this has been coded already, right? So someone has gone here and put in the value 1 for male and 2 for female. If I were going to code another value, I would put in a 3, type in other, and click add. Okay, obviously that doesn't make any sense. So I'm going to click that and I'm going to remove. Right? So it's 1 for male, 2 for females, but that's the way I would code data. This is where SPSS gets the information in the data file that we saw that tells it that this particular baby, which had a value of 1, was a male baby, and this baby, which had a value of 2, is a female baby. Okay, so we have all this data now. We have some numerical data. We have some categorical data. Okay, I'm going to break for a second. I'm just going to look over here to the chat box. Does anyone have a question so far? Let me know if you want me to turn on the microphone temporarily, or if you just want to type in a question or something like that. I want to make sure that I haven't lost you, or if I have lost you, I haven't lost you too much. How do we feel about what we've seen so far? Are we okay with it? Okay, good. All right, I got one response. All right, good. Just wanted to make sure. Okay, also, I do that every once in a while just to make sure that this whole thing hasn't crashed and then I'm not talking to myself. So you have to humor me a little bit here. Okay, so let's take a look at this. So now let's do some analysis on this data. And if you look at the exercise, the first thing that we're looking at in the exercise, part number 1, was looking at frequencies. Remember, I mentioned before that frequencies are important for nominal data. For instance, if we sample 100 people and we're checking eye color, we're interested in, how many people have blue eyes, how many people have brown eyes, so on and so forth. We're interested in the frequencies, the numbers of those people. Okay, so I'm going to go over here. Let's say for sex, I'm interested in, it's a nominal variable, the sex of the baby. How many babies are males out of these 800? How many are females? So the way I'm going to do this is I always, when I'm starting an analysis, I virtually always almost go up to this selection, analyze. Right? Analyze gives me a lot of options. Reports, I'm not going to worry about that for right now. Notice it'll print out a code book. Descriptive statistics, which is mostly what we're doing these 2 weeks. And the first option is frequencies. And frequencies is really what we're after. I'm going to click on frequencies and I'm going to look for the variable. Now, SPSS, as it frequently does, gives me a box listing all of the variables. And it shows with a symbol which ones are nominal variables. I don't know what that symbol means, but that's a nominal variable. I have no clue why. I guess it's red, blue, green, or something like that. Maybe it's colors. That's what how they indicate nominal variables or categories. But it's kind of an odd symbol. But trust me, those are nominal variables. And these ones with the rulers are scalar variables or numerical variables. Age, weight gained, notice drank alcohol during pregnancy is nominal because it's yes or a no, and so on and so forth. So for our purpose, we're interested in the sex of the baby. So I'm going to move that into the variables that we want to work with. I can move more variables in there. I'm just going to examine this one variable for the moment. Okay, and we're examining frequencies. I'm going to click on statistics just to look at that and see what's back there. Well, look, we have a number of choices here, right? So mean, median. Well, we know that these don't mean anything when we're dealing with frequencies, so I'm not going to check any of those. Quartiles, that kind of stuff. These are all really things that are intended for not for frequencies so much, but for numerical variables. Okay, so it really isn't too much there that I'm really interested in. So I'm going to cancel that. In fact, I wonder why SPSS didn't even just grade these out so you couldn't choose them. Charts, it gives us an option of selecting whether or not we want to print out some charts. I think we're going to want to print out some charts. I'm not going to select it for right now because we're going to talk about charts in a second. And I want to know what kind of charts that would be most appropriate to this. So I'm not going to worry about that. I'm not going to bypass format. And I'm just going to ask it to go ahead and do this display frequency tables is checked because that's what we're after. Okay, I'm just going to say okay and ask it to go ahead and do this calculation. Okay. Somebody mentioned that I'm off the big screen in C06. Am I off the big screen because it went to screensaver or something like that? Oh, okay, good. Yeah, it might have just blanked out for. Sometimes that happens. It blanks out for a moment. Okay, let me do that again. Okay, because it seems like we missed that for a second. I want to do that anyway because I want to mention what this thing is that popped open. I'm going to say analyze descriptive statistics. Because I'm dealing with a nominal variable, I'm going to say frequencies. It remembered that I moved sex of the child from here into the box that lists the variables that I want to work with. And now I'm going to just say, okay, go ahead and display those frequency tables for me. I'm going to click OK. And SPSS almost immediately, very quickly, comes up with some data for me. First thing it does is give me statistics that tell me that the sample size is 800, which we knew, and there's no missing data. There's no blank spaces in that data. It tells me that there's 418 males, 382 females. The percentage of males is 52.3%. Right? So we get a lot of data there. We get a lot of information. I'm just glancing at a question. That's why I paused. Okay, SPSS. Just so you guys know, SPSS and Excel can be used independently of each other. The only reason that I'm connecting the two here is to show you that there's ways to solve the same problems in one piece of software and in the other piece of software. Once you get working with this stuff, I probably think that if SPSS is available to you, you very rarely would go back and use Excel simply because SPSS does all of this faster and easier. Okay, and formats graphs much more easily, and so on and so forth. So you're going to find that Excel was nice for us to work with last week because we were able to use it very effectively to demonstrate how a sum of squares is calculated, how variance is calculated, how standard deviation is calculated, how the median is found, how the mode is found. It's very convenient for us to actually use that on a simple problem to actually do the calculations hands on. If you really want to do it with a big data set, well, it's much easier just to use SPSS to say, go ahead and do it. So, in a lot of ways, you may be leaving Excel in the dust here when you start to use SPSS. But Excel is an excellent piece of software, and you're going to find a lot of applications for it as you move on in your career, particularly you guys that are going to be doing a lot of data analysis and a lot of calculations. The environmental majors, the EOHS people, the MPH people that are taking EOH courses, many other kinds of calculations that you might use it for. Not to mention just life calculations. It's a pretty valuable piece of it's a valuable tool. Okay, so this is the way I would calculate the frequencies. Now, it would not make sense for me to calculate frequencies for a numerical variable. Let me just to show you what kind of mess that can be. Let me do that. Descriptive statistics frequencies. I'm going to move the gender of the baby out of there. I'm going to put the age of the mother in there. Okay, so now let's see what happens if I ask it to display frequency tables. I'm going to click OK. And look at this. It gives me the frequency. Let's see. Actually, this is not so bad, I guess, right? It gave me the frequency for every age that's reported. The age is reported as 2 digits, so this is not so bad. If the age had been reported as 15 years, 1 month, and 2 days, and 16 years, 1 month and 3 days or 4 days or 7 days, it would have listed every value here as a different value. Let me try it. Maybe there's another variable that would demonstrate that a little bit better. Descript frequencies. Actually, it's not such a bad thing. The age one is not it might be even a little useful. How about weight gained during pregnancy? Now that's also one that has weight in, let's say, weight of child in, I think that's in grams. That's the weight of the child in grams. Let's see what happens if we ask it to do a frequency table for that. Well, look, this doesn't give us much good, does it? Because every child basically weighs a different amount in grams, right? So it's really not telling it. All it's doing is listing every child here. And every one of them has a frequency of 1 practically. Well, there are 4 children that by chance have a frequency of 2,126.25 grams. But you see, frequencies doesn't make sense usually for numerical data. It's something that we use primarily for categorical or nominal data. I use those terms interchangeably. Okay, so I'm going to go back here to analyze descriptive statistics. I'm going to go to frequencies again. I'm going to go back to the sex of the child. I'm going to move that in there. And this time I'm going to click on charts. Now, there's a couple of ways for us to get tables or charts, graphics or charts out of SPSS. One way is to use a drop menu here called graphs. Right now it's not available because I have this other window open. But I could generate a graph from the data just by clicking on there, just as I would analyze data by clicking on analyze, right? But very frequently, the analysis function also includes an option to produce graphs as well, just to make it easier for you to do a couple of things at the same time. Now, does anyone want to suggest to me for the gender of the baby, which of these 3 options would be appropriate here? Bar charts, pie charts, or histograms? Okay, pie chart's good. I like pie chart, right? Because we'll see how many males and females and stuff like that. Any other opinions? Any others that would be okay? Oh, I see histograms. I see bar chart. Okay, let me back this up. Let's take a look at this. Bar charts make sense because a bar chart you would have a bar, the height that represents males, and a bar that represents females. Histograms are a special version of bar chart. For categorical data, we don't calculate histograms, okay? Because we're looking for a distribution like we would for ages, the mother's age, we would for the baby's weights, and so on and so forth. When we move up a little bit further, we'll understand that a little bit better. But for now, the types of charts that are appropriate for nominal data or categorical data are bar charts or pie charts. I'm going to do pie charts first, and I'm going to say OK. It's going to repeat the calculation it normally does. This is the same thing we did before. Okay, except this time we got a pie chart like you saw in the lecture for the sex of the child. So we can see that we have more male children than female children, but it's kind of hard to really make a judgment on what the percentages are and so on and so forth. I'm going to go back to analyze descriptive statistics frequencies, except this time I'm going to say on charts, let's do a bar chart instead. I'm going to say OK. Okay, and there it does. We do it again. And this time we actually can see the numbers a little bit better. We can see relative to each other, what they look like and so on and so forth. And this is a little bit more descriptive. Okay, I'm going to do it one more time. Descriptive statistics, frequencies, and display frequency tables. Let me see if I can't get it to show me. Nope, I can't do it here. Okay. I wanted to show percentages and stuff like that. Now you can double click into this or any of these charts and open an editing window. And in this editing window, you can do things like edit the text and the properties, the color and so on and so forth of the menu items and the height and the width of the graph and so on and so forth. But we'll get to that eventually. We're not too worried about that right now. But what I do want to show you is that this chart is a bar chart. Notice that there's a gap between them, male and female, right? It's either one or the other. If we have numerical data, we don't have a gap between the columns. The reason why we don't have a gap between these columns, between the columns, is because on the bottom here on the x-axis, there would be each bar would represent a range in numbers. Like a mother's age is between 15 and 20, 20 and 25, 25 and 30, 35 and 40. We wouldn't want a gap between them because if there was a gap between them, well, let's say that the age of a particular woman fell in that gap, we would have nowhere to put that value. So there's no gaps between them. They're continuous. If it were age, it might go from 20 to 24.9999, and then from the next box would be 25 to 29.9999, and so on and so forth. We could add labels and so on and so forth to that as well. It's going to be easier to do in another function. Remember, these are quick charts that we're getting because they're kind of a bonus to doing the analysis. Now, another way that we could create charts is to go up here to graphs. Now, there's three different ways to make graphs here. There's a template type situation. There's a chart builder, which steps you through it. But we old people like to use what they call the legacy dialogues. Okay, and actually you can go in here and actually tell it a little bit more simply. I want to create a pie chart. I'll define it, and I can move the variables in here. I'm going to wait a little while before we get into that. I can get it to show the percentages or the number of cases in each group, sex of the child. Oops, see if I can get it in there. We'll do this in a second. We'll go back to this later because I want to move on to histograms and some of the other information that we got. Got a question there. Read pie charts. We add labels. That's a good question. I don't know why they call it, why they would use, I guess gender or sex would be, um, uh, 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 I guess, interchangeable. The only reason I guess gender is obviously a male. Sex could be male, excuse me, gender is obviously a noun. Sex could be a verb, it could be a noun, it could be an adjective. So I guess gender might be a little bit more descriptive for the gender of the baby rather than sex. I guess sex is easier because it's just three letters. I really, and in fact, let me show you something else that's interesting. Now, remember in SPSS, we work with different windows for different functions. Whenever I did a calculation, it put the results into an output window. Everything we've done so far has been added on to the bottom of this output window. I can scroll up through here. It's got a little navigation window over here. This is the first frequency I calculated. This is the next exercise I did, and the next one, and the next one. So you can bounce around here by looking in the navigation window, or you can just scroll up and down if the navigation window isn't too high. So the output window is where all of your results are stored. Okay, the actual data stays forever in the data window. And there's also a third window called the syntax window, which is not open right now. It'll pop open when we do a calculation briefly, which shows you the description in SPSS's programming language on how that you would describe the process that you executed using the menus. Okay, now I just wanted to show you. Let's see. We got the output window, the input window. And somebody just asked me about applying labels, also about applying. I know what it was. We're talking about gender, whether it was gender or sex. The variable name that was assigned here is sex. I'm going to click the variable view, and if you look, the name of the variable is always in the first column. The plurality, sex, mother's age, those are the variable names. SPSS has rules about those variable names. Those variable names can't have any spaces in them. They have to start with a letter. They can have letters or numbers in them, and they can't have any unusual characters like asterisks and slashes and stuff like that. So there's a lot of rules that are a little bit restrictive there. So for instance, MH, we know that to be the mother's age because we interpret it that way. However, if we produce a table or a chart, we don't want it to say MH for the description of the data because that means something to us, but it may not mean anything to the person that's reading the material that we're producing. Okay, so we have not just a way to define the values, like what does one or two represent for males, but we also have a column that's called label. And in label, we have the opportunity to describe what MH means. So, for instance, plurality, the variable plurality means the number of children born of the pregnancy. Okay, that's, remember, I didn't know what that was. Now we have a description in this label that tells me exactly what it is. So plurality was a shortcut or a nickname for this data. This is the actual description of it. We couldn't use this description as the variable name because it has spaces in it. It may be too long also. Okay, so that's what that stands for. Mother's MH is actually the age of the mother in years. You can actually type this in. Someone actually had to code this in. When we imported this from Excel, all of these label fields were blank. It had to be coded in. Okay, so what will happen now if I produce a graph of the mother's age, if I produce a chart of the mother's age, SPSS now, instead of putting MH into the axes or the description of the chart, it'll use the label, making the chart or the output much more useful for us. And I think you probably saw a demonstration of this already in the output window. Let me open the output window. Okay, let's take a look at it. Output window. Okay, let me see. Here we go. Notice in the sex of the child, okay, the chart is described sex of the child, not sex. Where did it get sex of the child? From the label. So it substituted the label for the variable name there. And it substituted male and female, which it got from the data values for the 1 and 2 as well. So it made this chart much more useful. Sex of the child there, and so on and so forth. And even here, where we were working with the something we really didn't want was a frequency of a numerical variable. Weight of the child is the description rather than t grams, which was the variable name. So it's much more useful for us to get this. Now, what's the value of all this? Well, the value of all this is that later on, when you produce reports, right? For instance, you may want to produce a chart in SPSS and use it in a report. So, for instance, I'm going to take this pie chart. I'm going to say copy. I'm going to open a Microsoft Word document, okay, like this one. I'm going to say edit and paste. Now I have a couple of options here. I can say paste or paste special. If I say paste, it will go ahead and paste this. Maybe I didn't copy it right. Let me see. Edit, paste. Nope. Let me try again. Edit, copy. Okay. Let me go here. Hopefully I'll have a little bit better luck here. And see if it pasted. That's interesting. Have some sort of bug here. Try paste special. Yeah, picture. It's a picture, all right. There it goes. Okay. Now it pasted it into this document. I can move it around this document. I can change the size of it and so on and so forth. I can incorporate it into a report and so on and so forth. Here's the other version of it. It did paste it in. I just didn't see them. Probably went to the next page and I didn't bother. See, I'm backing out and I'm removing all the ones that I copied in there. So there's a lot of things that I can do this. I'm going to reduce it a little bit bigger, a little bit smaller, use it in a report and so on and so forth. You can do the same thing with the tables. If I go back here, if I want to use this frequency table, I can say copy, and I can go back to Microsoft Word, and I can say, let's paste this table right there. Okay, and it drops the table in there. Now, I did that and pasted it into place. Zoom in there. I pasted it into place. The way I pasted it in, it automatically went in on as a formatted table. If I want, I can double click on this and I can do things like highlight things. I'll make it bold. I can change color. I can edit the titles and so on and so forth. I can edit this. The downside is that this fit in here very comfortably because it's a relatively small table, right? If it were a big table with a lot of columns, it would have spilled off the end and the edge of the page. I would have had to go in here and reformat it and so on and so forth, which can be a see, you'll notice all the tabs. Notice all the tabs that are involved up here in reformatting. It can be a little inconvenient. The other option I have for pasting it is to say edit, paste special. When I say paste special, it gives me a number of different options. Pasting it in as formatted text, basically a box, as unformatted text, or pasting it in as a picture. If I paste it in as a picture, I have more flexibility over quickly and easily resizing and moving the table around. The downside is it's a picture, so I can't go in here and change, colors of text or highlight a number or anything like that once it's pasted in as a picture. I could, if I wanted to, open this up so that I can edit it in SPSS. Notice I can click in here and there's a window open that you don't see that'll allow me to edit this as well. I don't want to get too far ahead of ourselves here, but that's one of the reasons, that's one of the things that really makes this kind of useful. Okay, I went off on a little bit of a tangent, so I'm going to just take a moment and ask you guys, forgive me for going off on a tangent, but I want to ask you guys, are you okay so far? Any questions at this stage? Okay, and one of the questions was, when you say the label column needs to be coded, does that mean typing up the names you wanted to use? Yeah, it's a little bit more than just the names. For instance, when we imported the Excel file, all it told us was the name of the variable. Okay, we had to tell it. We could tell it what the width is that we want the number. When we want it to display, how many decimal places do we want it to display? What the width of the number is, whether it's 2 digits or 12 digits. We can tell it a label. We can tell it if it's a categorical variable. We can tell it what the numbers represent. For instance, for Hispanic mom, it's different letters. C is Cuban, M is Mexican, N is non-Hispanic, so on and so forth. We can tell it what those symbols represent that are actually typed into the data. We can tell it if there are missing values, what to do with the missing values, whether to ignore them, whether to, if there's a missing value for one of the variables, whether that means we should ignore the entire row of data for that person, and so on and so forth. We can give it rules about how to handle missing data. We can tell it how wide we want the column to be. We can tell it how to align the column. We can tell it what type of data is. Is it nominal or is it ordinal or numerical? Notice it left out numerical. Why did it leave out numerical? Because we just looked under Hispanic mom and there were only letters, no numbers, so it can't possibly be numerical. So it didn't even give us that option. Okay, it could have been ordinal because it could have been A, B, C, D, for instance, grades, and so on and so forth. And what kind of data it is. We'll worry about this later on. This is not really relevant to us at this stage, but it's a lot of information that you can code or define about this variable. And typically, when you're a researcher, you're going to make up a code book. You're going to write down what kind of data it is and what these things represent, so that when you get to SPSS, you can properly code this or properly explain to SPSS what this means. Okay, I'm going to move on because it looks like we're okay so far. Okay, so let's take a look at the next exercise.